Imagine throwing a potluck dinner with 10 friends. You want a balanced spread, some appetizers, mains and desserts. Everyone acts in their own interest. Some love dessert, some don't care about vegetables. How do you ensure the table ends up with everything you want, without micromanaging each guest? This is the essence of mechanism design, sometimes called reverse game theory. Unlike traditional game theory, which asks, what will people do given the rules? Mechanism design flips the question. How can we create rules so that self-interested players naturally produce the outcome we want? It's strategy flipped on its head, designing the game instead of just predicting the moves. Mechanism design is about creating systems, rules, or institutions that guide strategic players toward desired outcomes. Imagine you're the host of the potluck. If you simply say, bring anything you like, you might end up with 10 desserts and no main dishes. Instead, you could assign categories or give small rewards. Bring an appetizer and earn extra points toward dessert. Suddenly, everyone acting in their own interest leads to a balanced spread. That's mechanism design in action, designing incentives so that self-interest produces the result you want. In economics, mechanism design is everywhere. Governments use it to structure auctions for radio spectrum. Companies use it to design contracts that align employee behavior with company goals. Online platforms like Uber or Airbnb use it to shape driver and user behavior through rating systems and surge pricing. Even the school assignment algorithms that decide which student goes to which school are examples of mechanism design in action. At the core of mechanism design is incentives. If you want people to act a certain way, you must make it in their best interest to do so. Take auctions as an example. Suppose the government wants to sell a valuable radio license. They could just ask companies to submit bids. But how can they be sure each company bids its true value? If the rules aren't carefully designed, companies might underbid to save money, and the resource could go to a lower value user. This is where Vickrey auctions come in. In a Vickrey auction, the highest bidder wins but pays the second highest bid. This simple twist encourages bidders to submit their true valuation, because overbidding doesn't help, and underbidding risks losing the item. Suddenly, honesty is the best strategy, and the auctioneer achieves the goal of allocating the resource efficiently. Let's return to our potluck analogy. You could say, bring an appetizer and you get a dessert ticket. Guests naturally follow the rule because it aligns with their self-interest. They want dessert. This illustrates the fundamental principle of mechanism design. Design the rules so that the rational choice for each participant coincides with the outcome you want. Mechanism design also helps solve principal-agent problems. A principal hires an agent to act on their behalf, but the agent has private information or goals that might not perfectly align with the principal's. For instance, a company hires a manager to maximize profits, but the manager might prefer short-term perks over long-term gains. How can the company ensure that the manager acts in the company's best interest? The solution lies in designing incentives. Bonuses tied to revenue, stock options, or performance metrics encourage the manager to make decisions that benefit the company. Without these incentives, the manager may act purely in self-interest, and the company suffers. This is the same logic used in contracts, insurance schemes, and even employee evaluations. Think of hiring a babysitter. You can't watch every second, but you set clear rules, routines, and small rewards. The babysitter, acting in their own interest, naturally behaves in the way you desire. Mechanism design is everywhere once you start noticing it, from everyday life to high-stakes economic systems. One of the most famous applications of mechanism design is auctions. In the 1990s, governments struggled to allocate radio spectrum efficiently. Some early auctions failed because companies colluded or underbid. Economists like Paul Milgram and Robert Wilson developed new auction formats that encouraged truthful bidding, rewarded efficiency, and minimized waste. The results were dramatic. Billions of dollars raised, and resources allocated to those who valued them most. Another example is school choice programs. Cities need to assign thousands of students to schools based on preferences and capacities. Without a well-designed mechanism, families could game the system, leading to inefficiencies and unfairness. By using algorithms that reward truth-telling and match students optimally, cities can ensure fairness and efficiency, a real-life demonstration of reverse game theory at work. Even online platforms rely on mechanism design. eBay uses auction rules to encourage honest bidding. Uber uses surge pricing to balance driver availability with rider demand. Airbnb's rating system encourages hosts and guests to behave reliably. Each system is designed so that participants, acting in their own interest, help the platform achieve its goals. Let's try a quick thought experiment. Imagine you're designing a neighborhood carpool system. You want enough drivers for everyone but don't want anyone to drive too often. How would you design incentives so that everyone participates fairly? Pause and think. Would you offer points, rotate drivers, or charge a fee? Mechanism design is about asking these questions and creating the rules so participants' self-interest naturally leads to the desired outcome. Another experiment: a city wants citizens to reduce water consumption. Simply telling them to save water may not work. But if you design a pricing system that rewards low usage, people will voluntarily act in ways that align with the city's goal. Mechanism design is about structuring choices and payoffs so that rational, selfish behavior produces socially desirable outcomes. Reverse game theory, or mechanism design, flips traditional game theory on its head. Instead of predicting what players will do, it asks, how can we design the rules so that players acting in their own self-interest naturally produce the outcome we want? From auctions and school assignments to corporate contracts and public policies, mechanism design is everywhere. The key lesson is simple but powerful. Well-designed rules guide behavior more effectively than trying to change people themselves. By combining incentives with insights about how people actually behave, we unlock even more powerful ways to predict and influence outcomes in the real world.